Okay, hopefully that hyped you up to get started on this practice test. Okay, first thing when I'm looking at this problem, I notice that I just have one x. There's not going to be any holes. There's not going to be any holes because I have just this one on the bottom that can't cancel out. So this is going to move it left 3, down 2. So when I say it, you have to know what that stands for. That will be these asymptotes. X moves left and right. X moves left and right, and it's a vertical asymptote because it moves left and right. So my vertical asymptote would be x equals -3. My horizontal asymptote would be y equals -2 because y moves up and down. These repeat. Your domain and range are depending on what your asymptotes are. So this is saying my x value will never be -3. My y value will never be -2. Never. I'm going to first plot these points. So here's x at -3. If you're unsure what the direction should be, this line when at x is -3 should always have x -3. It should go in the order or in the direction of the tick mark as if you were to draw the graph. And y is -2. Maybe it right here. By the way, if you are unsure, that song was called Crazy Train by Ozzy Osbourne, one of my faves. My point or points of discontinuity, this would be like x equals -3 because it's not going to be fluent there. To be honest, I'm not going to care about that spot. I'm going to see your representation on your graph. So x-intercept means if I plug 0 in for y, what's my x? So I could use my calculator. Actually, I'm going to do that for my y-intercept. Kidding. Plug 0 in for x and figure out my y. But first I'm going to do with x. So I plug 0 in for y, and I'm going to solve for my x. The first thing I'm going to do is move this subtract 2. So I'm going to add 2 over. So I have 2 is equal to this 4 divided by x plus 3. I personally do not like to do with fractions, plus you should try to move the x, the variable, the unknown, to the not be in the denominator. So I'm going to multiply x plus 3 over on the other side to keep it even. Now you could divide by this 2 here, or else you can distribute. I'm personally going to distribute. So this would become 2x plus 6 is equal to 4. I'm going to subtract over my 6, so that would give me -2, and divide by 2, which gives me -1. So I can plot that point. -1, 0 would be right here. Now I'm going to plug this into my calculator, this equation. This is how I would plug it into my calculator. You need to have parentheses around there. I'm going to go to my table, because if I plug 0 in for x, I see my answer would be -2/3. You could also plug it in if you were like, what if I don't know what the fraction would be? Well, if you plug 0 in for x, it would look like this, because that would be the 0 in that spot, and I can go 4 divided by, in parentheses, 0 plus 3, and then subtract 2. See that decimal? And I can go to math, change it to a fraction. You get -2/3. I'm going to go back to my table though. Second graph to get to table. I'm going to find these other numbers to plot. So now I have enough numbers so I can kind of see where that curve should be. And that looks like that. So again, when I'm grading this, I need to clearly see where your asymptotes are. If you're watching or going to be hand drawing this, make sure I can clearly see your tick marks. I need to see points so I can see that you have your curve correct. So the second one, I see more than one x here, so this might have some holes. First thing I'm going to do is factor. On the top, I can take out an x or a 5, so this would be x plus 3. On bottom, I can factor be x plus 3 and x minus 3. So before I do anything else, I'm going to find my asymptotes. So my point of discontinuity, so that's going to be both these points. This is the same thing as up here, so I could have written that down too. My point of discontinuity would be what x can't be down here. So x cannot be -3 and +3. Now these points of discontinuity are not always going to be vertical asymptotes like the top. First I have to look at this and see where can I cancel. You can only cancel with multiplication in between. So I can cancel this x plus 3 and this x plus 3. Anything that cancels now becomes a whole. So this is what I'm left with. This is what canceled. This is the restriction that canceled. So now I'm going to have a whole at -3. Notice how I'm not just putting -3, I put a comma because I'm actually going to state where that whole is. These two simplify. Now I'm also going to be looking at I'm going to come back to this. I'm also going to be looking at my asymptote. When I'm looking at my asymptote, I'm looking right here at my original. Okay, looking always at my original. Now, if these were the same, it's the number out in front. If this has the higher degree, if the top has a high degree, then there's no asymptote. But now, since this has a higher degree on bottom, then my asymptote is always going to be at 1. Y equals 1. Okay, so I have 2 points of discontinuity. One is a whole. That means this other one is going to be an asymptote. So x equals 3. Remember, these two, I didn't even write. I don't have range on here. Lucky ducks. My domain would be x cannot equal -3 and 3. These two should be matching. If I did put the range, it would be y cannot equal 0 because of this right here. So first thing I'm going to do is draw in my lines. So here's my lines. I'm now going to find my whole. So -3, I plug that into this equation. So 5 over, I'm plugging -3, so I'm looking for my whole. I'll put a hole there. Looking for my whole, -3 minus 3, which would be 5 over -6. 5 over -6. So when I plot this, -3, and that's about almost -1. So I'm going to put a hole. I have to clearly be able to see that point. Now I'm going to plug it into my calculator. I'm purposely plugging in my original and my simplified. The reason why I'm doing this is because if I go to my table, notice how my original has 2 errors because both of those are points of discontinuity, so it doesn't happen. And notice how my simplified has this point. This point is where the whole is at. This point is where the whole is at. So that's a -5, 6, like what we just solved for here. So if I find my x-intercept, my y-intercept. So x-intercept by definition is saying when y is equal to 0. We have an asymptote. There is not an option to be on the x-axis because of this asymptote. So there's none available. Y-intercept means you're plugging 0 in for x. I'm going to plug it into my simplified equation only because it's going to be easier to do my mental math. Because 0 minus 3 would give me a -3, so this would be -5/3. So 0, and then -5/3 is almost to -2. So if I go back to this table, it doesn't matter which ones actually I'm looking at. I'm going to plug in 2, -5, 2, 1, 2, 3, 4, 5. There's probably enough over on this side to draw my curve. So I'm not going to go through my hole. Ooh, beautiful. Just look at that. That's beautiful. 4, 1, 2, 3, 4, 5. What? Any other nice numbers? Oh, here's a nice number. 8, 1. That should be nice enough. Again, it should be a curve. You should not have a straight line. There you go. And I'm grading this, making sure that you have your whole and your intercepts correctly and correctly graphed, and your asymptotes correct. So it's saying that this is my original. It's saying these are where my asymptotes are. Draw the new equation. So my equation typically looks like this. So this is my vertical asymptote. That's the number with my x. So my vertical asymptote, I'm putting the 2 right here because of this 2 in my original. It's a +4. That means this is opposite, so this would be a -4. My k is what my y is equal to, my horizontal asymptote. And because it's negative, it'll be a -8. This one's just asking to find asymptotes. So I don't have to factor, I don't have to do anything. I'm just looking at this portion, your leading coefficients. Looking at these 2 leading coefficients, my degree on both top and bottom is the exact same. So that means that my horizontal asymptote would be the 2 numbers out in front of these leading coefficients. 8 divided by 2 is y. So I would have an asymptote, 8 divided by 2 is 4, not y. So my asymptote is at y equals 4. Then looking at this, my degree on top is smaller. My degree on top is smaller, that means my asymptote's at 0. A lot of times people are able to see that if I had a problem like this, I don't know, my asymptote's at 0 because I don't move up and down. Look at how there's an x on the bottom. It's the same thinking process. If more x's are on bottom, no matter what, if more x's are on bottom, asymptote at 0. Simplify and state any restrictions. So first thing I'm going to do is state my restrictions so I don't forget. I'm multiplying across, so I'm just having my x and y. Both x and y cannot equal 0, and y cannot equal 0. There's no adding and subtracting there. There's two ways you can do this. You can simplify before or multiply across. So if I multiply across, I would have that 7 times 12, so 84, that's an 8. 24 times 21, 504. And then I'll have x to the fourth, y to the fourth, x, y to the fifth. I can do the 84 divided by 504 in my calculator and then change to a fraction. So that's going to be 1/6. So over here, you don't have to have that one on top, but you sure can. Looking at my x's, I have more x's on top, so my x will end up being on top. 4 take away, there's only 1 there, so that'd be 3 left over. My y's, there's more y's on bottom. 5 take away 4, there's 1, you don't have to represent that. If you simplified before you multiplied, I can go, okay, 7 and 21 can simplify to be 1 and 3. 12 and 24 could simplify to be 1 and 2. So that's where my 1 times 1 is 1. 2 times 3 is 6. Then you could simplify the x to the fourth over x, and then the y to the fourth over y. It's another way you could do it. Second one. First, I want to factor. So I have my 2x on top. Both of these have an x in common. Before I simplify anything else, I need to state my restrictions. X cannot equal. Because of this right here, there's no adding, subtracting, x can't equal 0. Because of this right here, we don't want this to be 0. X can't be -6. That's a 6. Because that would make that 0. Now I see where I can simplify. We're only if they're multiplying can you simplify. There's no adding, subtracting up here. That's why I can simplify. There's no adding, subtracting. Both of these x's would cancel each other out. Use a different color. So I'm left with 2 over x plus 6. Next. Oh my gosh, isn't math just so fun? I know, you'd think it too. First thing I'm going to do is simplify. And actually, because I'm multiplying across, I'm going to take an x here, leave me with x minus 6. And I'm multiplying across, so I'm still going to have my x plus 6. And then on top or on bottom, I'll have x plus 6 and x minus 6. And I still have this x squared. I personally like to have my x squared out in front. Now I personally am going to find my restrictions. So this cannot be 0. Because if it were 0, then the whole thing shebang would be 0. This parenthesis can't be -6 because it would make the whole thing 0. This cannot be +6. Now I can simplify. So only time when you're multiplying in between. So x plus 6 and this x plus 6 can cancel. X minus 6, x minus 6. A lot of people get confused. If you're confused here, write it out like this. Now I can have simplify an x on both top and bottom, leaving me with 1 over x as my final answer. In this next problem, always first factor. Before I do anything else, I want to state my restrictions. In this parenthesis, x cannot be +7 because that would make a 0. Those two are the same. For this x by itself, x can't be 0 because if this was 0, it would be 0 on the bottom and also a +7. Now, because I'm dividing by this fraction, I need to multiply by its reciprocal. So the first fraction does not change whatsoever. Now I'm multiplying, and I flip. So anything on bottom now becomes on top. Anything on top now becomes on bottom. Once you do this, you have to check to see if you have any new restrictions, and I do. Because I have x plus 7, x cannot be -7. Now with multiplying, go straight across. So I have an x plus, nope, I have an x minus 7 and an x minus 7. Here's an x minus 7, x minus 7. And that's all I have. Oh, I have an x plus 7, x plus 7. So all I'm left with is this right here. So I have x over 5. Adding, I have to first factor. So I have to find my common denominator. My common denominator would be x minus 3, x plus 2. Now I need 2 x plus 2's on this side, so I have to have another x plus 2. I have x minus 3, x plus 2, x plus 2. So this first equation, what I'm missing from here to here is an x plus 2 on both top and bottom. Now this, now is what's on the bottom, so I have to distribute this x to both. So I get x squared plus 2x. Here I'm missing an x minus 3 on both top and bottom. So again, now this is what's multiplied on the bottom. Distribute this. I have 4x minus 12. So now, since they're the same, so whenever adding, subtracting, you want to make sure to distribute. So I'm left with an x squared, 2x plus 4x would give me a 6x minus 12 over x minus 3, x plus 2, x plus 2. And I actually can't factor that at all. So my restrictions are going to be x cannot be, so once you actually combine them, x cannot be 3 or negative 2. I can't simplify this fraction. I can't factor it. So this right here is my final answer. If you want to write the x plus 2 squared, you sure can, or else you can write it out like that. So again, first step factor. So my common denominator here would be a 3x, x plus 3. Because you have to have everything from both fractions represented. So from here to here, I'm missing an x. So I have to multiply the top and bottom by x. So this becomes x times x is x squared. Now, once I multiply it, this looks like the bottom. Here, I'm missing the 3. So I have 3 times 3 is 9. I have the subtraction. You can go plus and then put the negative up here if you want. Now, since they're the same on both top and bottom, 3x, x plus 3, I have x squared minus 9. I can factor this. This can factor to be x plus 3, x minus 3. You also want to make sure before you simplify anything, you state your restrictions. This can't be 0, so x can't be 0. This cannot be negative 3 because that would make that 0. Now I can simplify in between multiplying and left at x minus 3 over 3x. So I'm going to highlight this right here is my division bar. My common denominator here just on top, when I'm looking just on top of this would be like x, or 1 would be like x over x. A lot of times when people are doing this is still adding together. So this division bar is not changing. This becomes x plus 1 over x, not just 1 times x, adding. And then I have the 3x. I can change this now to be x plus 1 over x times, and I flip this fraction, so x on top, 3 on bottom. Now because it's multiplying, those stick together if you want to go like this, but since these two x's are the exact same, those cancel, leaving me with x plus 1 over 3. Second, I first have to find my common denominators. So here's my division bar that I'm going to keep. My common denominator on the top would be x plus 2, x minus 2. So I'm missing this x minus 2. So I have to multiply the top and the bottom by x minus 2. This becomes 3x minus 6. Over here, I'm missing the x plus 2. So this becomes 5x plus 10. On bottom, my common denominator would be x plus 1, x minus 1. I'm missing the x minus 1 on both top and bottom, so I have to multiply the top and bottom. So again, this bottom, looks like what I have right here. 2 times x is 2x. 2 times negative 1 is negative 2. Here I'm missing my x plus 1, so I have to multiply by x plus 1 on both top and bottom. So this becomes 3x plus 3. Now again, I personally like to go like this. Ma'am, ma'am, thank you, ma'am. So this top is not changing yet. On top then, I have my x plus 2, x minus 2. 3x plus 5x would give me 8x. Negative 6 plus 10 would give me 4. And bottom does not change. 2x minus 3x would give me a negative x. Negative 2 minus 3 is a negative 5. So I'm going to take this first fraction. I'm going to take a 4 out of both of those. So I can factor out a 4, leaving with 2x plus 1 over x plus 2, x minus 2. I'm going to change this to multiplying. So anything on bottom now comes on top. I'm going to factor out a negative 1 here, leaving with x plus 5. Now this, I guess, is, I don't know if you think it's a good or bad thing, but nothing here cancels whatsoever. So my final answer will look like that. Since nothing cancels, that is it. Now getting to actual solving. So first I want to combine these two. My common denominator here will be 12. So this top portion is not going to change, or my first fraction. Here I'm going to multiply by 2 on both top and bottom. So I have 2 12ths, so equal to 1 6. So on the left-hand side, that 12, when I subtracted the 2, this would be like a plus and negative. So I have my 3x, negative 2 minus 2 would give me a negative 4. Now what I'm going to do is I'm just going to multiply by the 12 here. Sometimes you have to multiply by both, but in this case I noticed that this will actually cancel out here. And then here, this 12, remember they're multiplying by 12, so that's like 12 on 1. I can cancel this 12 with this 6, leaving me with 3x minus 4 would be equal to 2. Add over the 4. 3x would be equal to 6. Divide by 3. X is equal to 2. And there's no restrictions here because there's no x on bottom. For 15, my common denominator here first would be x plus 1, x minus 2. Forgot to push play. So here I have to multiply by x minus 2 over x minus 2 because that's what I'm missing from here to here. So distribute this becomes x squared, negative 2x. Here I'm missing an x plus 1 on both top and bottom. Distribute to both here. We get x squared plus x. So there's adding in between these. So on the left-hand side, I have x plus 1, x minus 2 on bottom. X squared plus x squared is 2x squared. Negative 2 plus 1x would give me negative x is equal to 2. I'm going to get rid of this division. So I'm going to multiply both sides by x plus 1 over x minus 2. Whatever you do to one side, you have to do to the other side. So on this side, I'm going to be left, actually, let me go like this. I'm going to be left with only the 2x squared minus x, because these two will cancel. Here, I'm going to first multiply these two out. So I have my first outside would give me x squared plus x. Inside x, this would be negative 2x. And last, minus 2. This whole thing gets multiplied by 2 right here. So what I really have, this becomes x squared minus x minus 2, with this 2 outside. So 2x squared minus 2x minus 4. So again, first multiply these, combine like terms, and then distribute the 2. So now I'm going to move everything over. Actually, I'm going to see what happens first, because I'll see if I subtract this 2x here, this 2x there, those two cancel. That's nice. I'm going to add this 2x over here, add the 2x over here, so I'm left with just x is negative 4. If I look at my beginning of my problem, x can be negative 4 because that's not part of my restrictions. Wham, bam, thank you, ma'am. I would say this one's a little bit easier just because I don't have to add and subtract first. So first I want to get rid of this division. So I'm going to multiply both sides by x plus 3. When I multiply both sides by x plus 3, these two cancel. When I multiply, or when I want to get rid of this division, I'm going to multiply this side by 2. And I'm going to multiply this side by 2. These two cancel. So on the left, 2 times 2 would give me 4. X plus 3 times x minus 3 at my first, outside, inside, last. So I'm left with 4x squared, or 4 equals x squared minus 9. Add over my 9. Take the square root. This is where you have to be careful because you're going to have 2 answers. Because that's not a perfect square, we leave it as a root. And the last one, finding my common denominator would be 2y. I'm not going to change that one at all. So I have to multiply this one by 2 over 2, which would give me 4. Multiply this by y over y, which would give me y. So on this left-hand side, I have 4 plus y over 2y and 5 over 2y. Now, because these denominators are the same, you could multiply by 2y on both sides, but on both sides, those will cancel. So 4 plus y equals 5. Subtract the 4, and you get 1. Is that a restriction? By golly, it's not. Y is equal to 1. Easy peasy lemon squeezy.